It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to this session. So this is S. Chand Academy, a YouTube channel of S. Chand Publishing. The book is JEE Mains and Advanced in Mathematics by ML Khanna sir and videos by me, Subuh Nadeem. So as we studied in the previous chapter, miscellaneous equations. In this chapter we are going to do permutations and combinations. This is chapter number 7. First of all, let us see some basic theories, recap them. So, law of addition and law of multiplication. What was law of addition? When we have two jobs or three jobs and any number of jobs, and if you do any one of the jobs, your work is completed. Then that it is said that the work is completed. That means job 1 is done in m ways, job n2 is done in n ways, and either of job 1 or job 2 is completed, then we say that the job is completed. That means either buy a bread or buy a roti from the market, your job is completed of eating something. So in that way, the job is said to be completed in m plus n ways. The number of ways in which you can buy a roti and the number of ways you can buy a bread. So total number of ways is m plus n. And if we talk about law of multiplication, what was law of multiplication? Law of multiplication was that if a job is completed in m ways and another job is completed in n ways, and your total job is completed if both of these jobs are completed. That means you have to buy a bread and a butter. Bread you can buy in 3 ways, butter you can buy in 4 ways. The number of ways in which get bread and butter is 3 into 4, that is m into n ways. That is the law of multiplication. So this is the basic law from which the permutation and combination concepts have evolved. Now there are few formula like NCR, number of ways in which you can select R objects out of n distinct objects, and its value is given as n factorial by R factorial into n minus R factorial. Similarly, NPR is also a term which is number of ways in which R objects can be arranged from n distinct objects. So value there is n factorial upon n minus R factorial. And we can also see that NCR is equal to NPR upon R factorial, or we can say that NPR is equal to NCR into R factorial. So for generally solving problems on permutation, we don't use the formula of permutation separately, but we use the formula of combination and then we multiply with R factorial for arrangement. This is a major way in which we do problem solving. We will see this in few of the applications. Now if we have, suppose n objects, and out of those n objects, some objects are similar, like p objects are similar. Out of these n objects, p alike and q are of different type and they are also alike. Then if we want to arrange them, then the number of ways is n factorial upon p factorial into q factorial. Similarly, if we have n objects and all are distinct, then it is simply n factorial because it is npn and npn is n factorial. Some of the basic formulas which we know is NCR minus 1 plus NCR is equal to n plus 1 CR. It is also a very important formula which we may use. Further, about circular arrangement. If we do a circular arrangement like this, suppose there is a table, circular table, and there are chairs around it. How many ways you can arrange n objects in n chairs or n persons in n chairs? So that will be done in n minus 1 factorial ways, not n factorial ways. Why? Because one object will be used to determine the starting point or to mark the point from where the row will begin, and then arrangement will be with respect to this fixed object. So remaining object is n minus 1. If it is a garland, then clockwise and anti-clockwise are same. That means clockwise and anti-clockwise will be obtained when you reverse the garland. So in that case, the number of ways of arrangement is n minus 1 factorial upon 2, half of that. Okay. Further, if we talk about distinct objects into groups, so if we have suppose m plus n objects and we want to divide them into groups, into two groups of m objects and n objects, and these objects are distinct, all of them are distinct. How many number of ways we can do it is m plus n cm into n cn, that is m plus n factorial upon m factorial into n factorial. This we call it division into groups. This is division into groups. But if it is asked that you don't have to do division, you have to do distribution. So if you want to do distribution, then it is done in how many number of ways? That means you will divide and then distribute among the people. So you have to further say m plus n factorial upon m factorial n factorial into 2 factorial, number of ways of arrangement. Second one is, okay, one more formula let me tell you. If it is about 2m objects and those 2m objects are break into two groups of m objects each, here there is a repetition. So in order to avoid repetition, we take 2m factorial upon m factorial into m factorial divided by 2 factorial for division, and for distribution we will say that we have to multiply by 2 factorial. So this is 2m factorial by m factorial into m factorial. So these are in detail, you can see in the book also, these were in the videos. Now let us see some of the questions. Find the value of 47C4 plus sigma r is equal to 1 to 5, 52 minus r C3. So when you will expand it, it will be 47C4 plus 52 minus 1, that will become 51C3, then 50C3, then 49C3, then 48C3, then 47C3. Now 48C3 plus 47C3, what will be this? If you remember the formula n minus r ncr minus 1 plus ncr, it is n plus 1 cr. So just use that particular formula. So here 47C3 plus 48C3, still you cannot use that formula here. So what you will do? You will don't combine this with this, instead combine this with this, 47C3 and 47C4. What this will give you is 48C4. Now let us write other terms. What are other terms? Plus 48C3, then plus 49C3, then 50C3, then 51C3, this one. Now again apply the same formula in these. So it will give you 49C4. Now combine it with this. You will get 50C4. Now combine this with this. You will get 51C4. Now combine with this, you will get 52C4. So finally the value will be 52C4. This will be your answer. Yeah. Now you need not find the value because it will be too big value and you don't have to do calculation. You will just say that 52C4 is its answer. Prove that n minus 1 C3 plus n minus 1 C4 is greater than n C3 if n is greater than 7. So n minus 1 C3 is n minus 1 factorial upon n minus 4 factorial into 3 factorial. That is the formula of NCR. If you remember, the formula was NCR is equal to n factorial by n minus r factorial into r factorial plus n minus 1 factorial upon n minus 5 factorial into 4 factorial greater than n factorial upon n minus 3 factorial into 3 factorial. Now n factorial is not going to be 0. Factorial of a whole number is not 0. For 0 it is 1, for 1 it is 1, for 2 onwards we know the natural numbers multiplication from 1 to n. So n factorial is not 0. So we can cancel is, let us first take common, n minus 1 factorial we can take common, n minus 5 factorial we can take common and 3 factorial we can take common. What remains inside is 1 by n minus 4 plus, here also you have taken common, so 1 by 4. On the right hand side it is n into n minus 1 factorial upon n minus 3 factorial is written as n minus 5 factorial into n minus 4 into n minus 3 into 3 factorial. Now when you divide, n minus 1 factorial will get cancelled, n minus 5 factorial will get cancelled and 3 factorial will get cancelled. So in the next step let us take LCM. So n minus 4 plus 4 in the numerator upon n minus 4 into 4 is greater than n upon n minus 4 into n minus 3. Now let us cancel n minus 4 from both the sides. So after cancelling this, or n minus 4 we are cancelling because n minus 1 is greater than 4, right? We know that in NCR n is greater than r or equal to r. So n minus 1 is greater than equal to 3, n minus 1 is greater than equal to 4, n is greater than equal to 3. From here n is greater than equal to 4, from here n is greater than equal to 5 and from here n is greater than equal to 3. Therefore, n is greater than equal to 5 is the condition, basic condition. So n minus 4 can easily be cancelled, it cannot become 0. In the next step, this will become cancelled, minus 4 plus 4. So n into n minus 3 is greater than 4n. So this will become n square minus 3n minus n minus 7n greater than 0. So this will give you n into n minus 7 greater than 0. Since n is positive, so n minus 7 is positive, that means n is greater than 7. This will be your answer. So if n is greater than 7, that is what we have obtained. Please like, subscribe and share the video and also hit the bell notification if you want to get the notification about the future videos. Now let's see the next question. How many different words can be formed with the letters of the word ordinate so that the vowels occupy odd places? So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 places are there. And this is one odd place, this is the third place, this is the fifth place, this is the seventh place. Now you can occupy these odd places with vowels. What are the vowels? Vowels are O, I, A, E. These are the vowels. And what are the consonants? R, D and T. These are the consonants. So in odd places you have to arrange vowel for the first part of the question. So for the 4 places 4 vowels are there that you can arrange in 4 factorial ways. And the rest 4 places will be filled by consonants that will also be in 4 factorial ways and none of them are getting repeated. So you can easily see that this is 24 into 24, that is 576 ways. This is a small number, so we calculated, otherwise we can leave it as it is. For second part, beginning with O. So out of the 8 places, first is beginning with O. First place is O. So in that situation, rest 7 places can be arranged in 7 factorial ways. So we'll just say 7 factorial. This will be our answer. Third one, beginning with O and ending with E. Now 8 places are there, beginning with O, ending with E. So how many ways this can be done is 6 factorial. That will be our answer. How many different words can be formed from the letter of the word intermediate? In how many of them 2 vowels never come together? So again, 2 parts of the question. First, how many number of words can be formed, meaningless or meaningful, it does not matter. So first of all, see I, it comes at how many places? 2 places. This I, then N is there. How many places it is? 1 place, only 1 place. Then T is at 1 and 1 more place, 2 place. E, 1 place, 2 place, 3 place. It is a vowel, so I am writing on the left. Consonant I am writing on the right. Then R, 1 place. M, 1 place. D, 1 place. A, 1 place. Okay, that is it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here it is 6, this side vowels, and here also 6 in consonants. So how many different words can be formed from the letters of the word intermediate? So first part of the question is asking how many words can be formed. So there are 12 letters, 12 factorial ways, and you have to eliminate the repeating words, a repeating set of letters. So I 2 times 2 factorial divided by this, then 3 factorial here, and for 2 factorial from here. So this will be your answer. For second part, it says in how many of them 2 vowels never come together. So if you want to see the total number of vowels are 6, and if you want to see the total number of consonants are also 6. So this is a gap method. In gap method, what we do, first let us arrange those which we don't have to, there is no condition upon that they are separated or they are joined. So consonants, there are no condition on them. So let us arrange consonants. So 1, 2, 3, 4, 5, 6. 6 places are being arranged by 6 consonant. In how many ways? 6 factorial ways upon 2 factorial ways, because T is repeated 2 times. Now next, let us come to vowels. So now vowels can occupy gaps 1, 2, 3, 4, 5, 6, 7 gaps, because they cannot be together. So those are all in the gaps, so that at least a consonant is in between, or sometimes more than one consonant may also be in between. But there is no 2 vowels together. So this we can do in 7 C6 ways, because there are 6 consonant vowels and 7 gaps. So we have selected 6 gaps for them, and then further we need to arrange those vowels. So there are 6 vowels. So 6 factorial upon repeating vowels are 2 factorial and 3 factorial. So this is how we have arranged it. So this is how you get the answer. You can do the calculation part if you want, and this is the answer basically. Now let us come to the next question. There are 21 balls which are either white or black, and the balls of the same color are alike. Okay. So let us suppose white balls are R and black balls are 21 minus R. So these R are alike and these 21 minus R are alike. Find the number of white balls so that the number of arrangement of these balls in a row be maximum. So the number of arrangement is to be maximum in a row, not in a circle, in a row. So how many ways you can do the arrangement? So that is 21 factorial upon r factorial into 21 minus r factorial, because we don't want to repeat alike objects. So that is why r alike objects r factorial is divided. 21 minus r alike black balls, that is 21 minus r factorial is divided. Now this is nothing but it is 21 CR. Now you want this to be maximum. This needs to be maximum. Under what condition this is maximum? So in binomial theorem we studied or we may study in the next few lectures that the maximum term is the middle term for binomial coefficients. So what is the middle term? So 21 middle is either 10 or 11. So R is either 10, that is 21 minus 1 by 2, or 21 plus 1 by 2, that is 10 or 11. So these will give you the maximum binomial coefficient value. So you will say that there are 21 balls which are either white or black and the balls of the same color are alike. The number of white balls are either 10 or 11. So both cases are possible. 11 white balls and 10 black balls. This will also give you the maximum number of arrangement, or 10 white balls and 11 black balls. This will also give you the same greatest number of arrangements possible. So both is possible. If it was 22, then one value will be, that is 11. Now let us come to the next question. A number of 6 different digits is formed by using the digits 0, 1, 2, 3, 4, 5. Find how many such numbers can be formed. So first question, if you want to find the total number of numbers formed, these type of questions very frequent in competitive exams depending upon the number of digits. Some are on number of letters, some are on number of digits. So here a number of 6 different digits is formed by using the digits 0, 1, 2, 3, 4, 5. Find how many such numbers can be formed. So first of all, there are 6 places, and one thing is to be clear that in the lakh place, or you can say 100,000th place, ones, tens, thousand, 10,000, ones, 10, 100,000, 10,000, 100,000 place, 0 cannot be placed, because in that case it won't be a 6-digit number, it will be a 5-digit number. So first let us see the total number of arrangement, that is 6 factorial. From that we subtract the number of ways of arrangement where 0 comes at this 100,000 place, that is 0 is here. Then there are 5 places and it can be arranged in 5 factorial ways. So this is our answer, 6 factorial minus 5 factorial. There is another way of doing this also, that you take 0 any one of these 5 places in 5 ways, and rest 5 places are arranged by 5 other numbers in 5 factorial ways. Both is the same answer. When you will solve this and solve, you will find out that both is same thing. One is by elimination, another by inclusion. Second question, second part of this question. How many of these are even? So if you want them to be even, so this place can be filled with 0, 2 or 4. So if it is placed with 0, then this can be arranged in 5 factorial ways, right? If it is arranged with 2, then rest 5 can be arranged in 5 places in 5 factorial ways, but you have to keep this in mind that 0 is not at 100 place, 100,000 place. So for that to be eliminated, again same thing you will do. You will take 0 at any one of the 4 places in 4 ways and rest 4 numbers in 4 factorial ways. Similarly for 4 at unit place, this will be 4 into 4 factorial. So the total number of ways is 5 factorial plus 2 into 4 into 4 factorial. Now you can calculate this and get the answer. C part. How many of these are divisible by 4? So if you want them to be divisible by 4, the last two digits must be divisible by 4. So how can this be possible? 0, 1, 0, 2, 0, 3, 0, 4 can give you. One possibility is 0, 4. 0, 5 won't give you. Now 1, 0, 1, 2 will give you. 1, 3, 1, 4, 1, 5. These are all not giving you. 2, 0 will give you. 2, 1 won't give you. 2, 3 won't. 2, 4 will give you. 2, 5 won't. 3, 0, 3, 1, 3, 2 will give you. 3, 4 and 3, 5 won't. 4, 0, 4, 1, 4, 2 won't give you. 4, 3 won't. 4, 5 will won't. 5, 0, 5, 1, 5, 2 will give you. These 5, 3 and 5, 4 won't give you. So 1, 2, 3, 4, 5, 6 cases seems to be there. 0, 4 and one more case would be there. 4, 0 will also be there, right? 4, 0 is also there. I missed that. 3, 2, 3, 4, 3, 5, 4, 0 will be there. 4, 1, 4, 2, 4, 3, 4, 5. Okay. So 1, 2, 3, 4, 5, 6, 7 cases are there. Out of these, zeros are used in 1, 2, 3. So first let us calculate for them. So if you want to arrange rest 4 places, then 4 factorial ways are there. So 4 factorial ways for 3 of them. So 3 into 4 factorial. Plus where zeros are not used, 1, 2, 3, 4 places are there. And if you take the 4 portions, 4 positions, so 0 cannot be used at the 100,000 place, then that case it will be 3 into 3 factorial. So 3 factorial ways you can arrange other 3 numbers other than 0, and for 0 any 3 places. So 3 into 3 factorial. And how many such are there? 1, 2, 3, 4. So 4 into 3 into 3 factorial. So this will give you the answer on adding. So this is how many of these are divisible by 4. Now lastly the question says how many of these are divisible by 25. How many of these are divisible by 25? So for that the end should be with 25 or 50. So for 25 if there is an end, then the ways are 3 into 3 factorial, right? And if 50 is how it ends, then there is 4 factorial. So this will give you the answer for the fourth one. So be cautious while solving the problems of permutation and combinations, that you won't be able to leave any question or any part or any aspect of the question, so that there may be some wrong answer which will come either by repetition or by elimination of some important aspect. Number of divisors of the form 4n plus 2, where n is greater than equal to 0 of the integer 240. So 240 is equal to 2 to the power 4 into 3 into 5 when you will factorize it. And how many divisors are there, you have to find out, of the form 4n plus 2. So 4n plus 2 is actually 2 into 2n plus 1. So 1 2 is to be taken, that is fixed, and that can be taken in one way. Any 1 2 you will take, all 2 are similar. And rest 2n plus 1 is an odd number, and that starts for n equal to 0, that is 1. So you can take 1, 3, 5 or 15, any of these 4 odd numbers. So numbers could be 2, 6, 10, 30. These are the numbers of the form 4n plus 2. And how many such numbers are there? 4 such numbers are there. Out of 8 men and 10 women, a committee consisting of 6 men and 5 women is to be formed. How many such committees can be formed when one particular man A refuses to be a member of the committee in which his boss B's wife is there? So, total men are 8, total women are 10. So, we have 8 men and 10 women, and we have to make a committee of 6 men and 5 women. And it is to be taken care that one man in the first list of men does not want to be with his boss B's wife from the women committee. So, how can this be done is, there are two methods. Method number 1 is the straight method, that from here I am taking that particular man inside the committee. A is inside the committee. So, A is inside and B wife outside. Then how many ways this can be done? So, 8 men, there are 7 remaining, and you have to select 5 because 1 is already there, and out of 9 you have to select 5. This is case A. Case B is A is outside and B wife is inside. So, out of 9 you have to select 6, and here out of B wife is already inside. So, out of 9 you have to select 4. C option. A is outside and B wife outside. Both are outside. So, out of 7 men, 6 men you have to select, and out of 9 women, 5 women you have to select. Now, the answer would be addition of all these 3 cases, that is 7C5 into 9C5 plus 9C6 into 9C4 plus 7C6 into 9C5. Next, there is an alternate method also, method 2. There we will take total number of ways of selecting in order to make the committee irrespective of any condition. So, 8C6 into 10C5. Now, eliminate the condition which is there. That means, if I take B's wife there and A also there. So, if both are inside, then the number of ways is 7C5 into 9C4. So, subtract that case from the total case. So, this will be the answer. So, this answer, when you will calculate, and this answer will be same. Both are correct answer. One is by elimination, one is by inclusion. This we have done by elimination, this by including all the cases, all the supporting cases. This by eliminating the non-supporting case from the total. Out of a crew of 43 persons on a ship, only 3 can do the steering and 1 is needed. Of the remaining 40, 8 persons wish to go only on one side and 3 persons wish to go on the other side. In how many ways can they be arranged so that there are 20 rowers on each side of the ship? So, first we have to select only one steerer out of 3. So, that can be taken as 3C1 ways. Now, of the remaining 40 rowers, 8 persons are wish to go only on one side, let us say left or right, any one side. So, 20 rowers has to be on one side, 20 on the other side. So 8 are fixed on the left side, suppose. So rest 12 have to be selected from how many? And 3 on the right. So 8 on the left, 3 on the right, out of the total 40. So how many left are remaining for the choice? So that is 29 are remaining. Now from those 29, you have to select 12 for the left one. So it will become 20. And rest remaining 17, you have to select all of them for the right. So it will also become 20. Now arrangement has also to be done. So left arrangement is 20 factorial ways, right arrangement is also in 20 factorial ways. So this is the number of ways in which this can be done. Okay. So this will be your answer. You can write the answer as it is, because generally options are also given in similar manner. At an election meeting, n speakers are to address the meeting. The only protocol to be observed is that whenever they speak, PM will speak before MP and MP will speak before MLA. In how many ways can the meeting be addressed? So basically, if you see that how many ways 10 speakers can speak, then the number of ways is 10 factorial. But there is a condition that MP, then PM, then MP, then MLA will speak. So in that case, there are 3 persons A, B, C, one PM, another MP, another MLA, A, B, C. 3 speakers are there. And in how many ways they can be arranged? So to arrange them is 3 factorial, that is 6 ways. Now you don't have to arrange them, you have to only select them in a particular order, PM, MP, MLA. So that 6 ways you have to divide. So you don't have to arrange them among themselves. So as we see that if there are some of the objects which are similar, then that number factorial has to be divided. Similar situation is coming here. Next question says, the total number of ways in which 5 balls of different colors can be distributed among 3 persons so that each person gets at least 1 ball is. So there are 5 balls in set A and 3 persons in set B. Now you have to do the arrangement of the balls to each persons so that none of the persons return empty handed. So this is type of onto questions. We have studied this also earlier, type of or number of onto functions. How do we calculate this? If you remember, first of all, allot these 5 balls to any one of them. First one can be given to 3, second can be given to 3, any 3. So in that case, 5 to the power 3 to the power 5 ways are there. 3 into 3 into 3 into 3 into 3. Minus, if suppose one is not allotted anything. So in 3C1 ways, that particular person is selected in which he is not allotted any of the balls. Now among rest 2, the distribution is to be done in 2 to the power 5 ways. So inclusion, then exclusion, then inclusion. Now 2 are not allotted any ball. So 3C2 ways, and only 1 ball is there which will be given to 1, 5 balls are there which will be given to only 1 person, 1 to the power 5. So this will become 243 minus 96 plus 3. So 150, this is a IIT question, this will be your answer here. So you have to be quite alert to solve these type of permutation combination questions, because there are chances that any time you may face any type of question. So all the best for this lecture. Thank you, students.